So in this case, we are going to consider another exam revision. That's to cater up for what we have covered on our vectors. We are given here on question number 10, OABCD is a pentagon, all right? It has got 5 sides from O to A to B, C, D. This is a 5-sided shape. Where we are given that AB is parallel to OD. So that is AB parallel to OD. Okay, but from the diagram, it seems something else. Look at how it is, but that is what we're given. They're saying these two, they are what? They are parallel. All right, and another statement, DC is parallel to OA. This DC and OA, this is basically given parallel, okay? And M is the midpoint of OC. This M is the midpoint of OC, meaning to say we've got equal distance from O to M and from M to C. We are going to have what? Equal distance. That is simply meaning to say OM is equal to MC. And we are given here, all right, midpoint of OC such that AM produced, all right, AM that is being produced cuts OD at X. This AM, when produced here, is going to cut OD at what? At X. Okay, so that is the information you are given. With this information, express these vectors, all right, in terms, all right, the following in terms of A and or B. So here there's an option that we can have both A and B, or we can have this concept of having A or B, meaning to say we can have an answer with A only, B only, or we can have that A and B on the same answer. That is the concept that you're given there. So don't be surprised if some answers are just maybe written in terms of B or maybe in terms of A only. All right, so we have to answer this and the other section of the questions, these ones. All right, so let us quickly consider the first part, item 1, AD. So item 1, we need vector AD. I'm just going to reduce a little bit here. Let's see. Yes, this is still fine. We can see here. So item 1, vector AD. So we need the root that we are going to consider to find the vector what? AD from this here to what? To D. From what we are given. Remember here they gave us here OA is vector A from O to A, and from O to D. From O to D, the whole part we are given as vector B. So meaning to say we can choose to use this route from O, from A to O, I mean, then from O to what? From O to D. That is from what we are given because we have these vectors here. So that was going to be A to O. That's vector AO plus from O to what? From O to D. So that is what you're going to have. So vector AD can be determined. A to O, we are opposing the arrow. The arrow is going the other way on the diagram as we're going the other direction. So that's a negative. So that's negative vector A plus, all right, let's consider OD. O to D, we are moving in the same direction as the arrow given there. So that's a positive vector B representing what? OD. So that was a positive, this one. All right. So that was it. And item 2, vector OX. So OX. So let us consider the route that we can take to obtain that given what? that given vector OX. So from O to X, this is our point O and this is X. This is it here, O to X. Okay. Remember, they gave us a ratio between OD and XD. This is collinear from the same line. Let us consider that ratio. We can have this part from X to D from the given ratio XD. Just divide by what? By 3 here. So vector XD is going to be 1 over 3 of what? OD. If we divide by 3, so it's 1 over 3 of what? OD. We have OD and X to D is 1 over 3 of OD, where OD is what? Is vector B. So that's simply 1 over 3 of what? Vector B here. 1 over 3 vector B from X to what? From X to D. So to find OX, are we seeing that OX is found on OD? So we can use a ratio if we want. Using the ratio, it was simply going to be this. Since XD is 1 over 3, 1 over 3, it means one part of the whole vector OD, which is what? 3 parts. If we analyze properly here, remember what I said, XD is the numerator, 1 part. The denominator here, 3, multiplying vector B, that vector B here is what? Okay, you can take it properly here, the XD, 1 part. Then the 3 represents what? OD. So OD has got what? 3 parts. Whereas from X to D, we have got 1 part. So meaning to say O to X has got how many parts? 3 minus 1, that's 2 parts. So OX can be written as 2 parts out of 3 of OD. 2 parts of OD. 2 out of 3 of OD. So that's it. OX 2 parts, 3 parts for what? For OD. Where we have that vector what? Vector OD as what? As vector given as B. So you're going to multiply 2 over 3 of what? Vector B. So that's it. Or you can work with a certain root from what we have. OD, we have that OD. So we can say OD, if we were to find that OD, it was going to be OX plus XD. All right, it was going to be OX plus what? Plus XD. So we have XD, this one. That's another way that you can find our OX. You're going to simply take OD. OD is what? From O to D, we have that. That's vector B is equal to vector OX that we want plus XD from X to D in the same direction. That is what? 1 over 3 vector B. So to find this vector OX, we're going to take 1 over 3 vector B here. So it's going to be a negative. It was a positive, so it changes the sign. So it's B minus 1 over 3 vector B, giving us what? Vector OX. That's another way that you could have determined your vector OX. So many ways, all right? So subtract here, these are like terms B and B. So 1 minus 1 over 3. 1 minus 1 over 3. The denominator is 3, so that's 3 over 3 minus 1 over 3, which is what? 2 over 3. So that was going to be 2 over 3 vector B. So that's it. We have got our vector OX. As we can see, same as before. So you can choose which one or which way is easier for you to determine such. Then AX, this was AX on item 3. We need to determine vector AX. we have OX. Remember, we have got the vector OX. We calculated this. And what we need is what? AX from A here to X. With the OX that we calculated, we can simply take our root this way from A to O, then O to X, since we calculated OX here. So that is going to be simply A to O plus OX. We have that. So let us substitute. A to O, you're opposing the arrow here. So that's a negative. Plus OX. We calculated this. We are in the same direction, and that's going to be a positive. So this is it. So that was our vector AX. From the given information, it's just as straightforward as that. All right. So let us consider another part from the given person. We also have this where we are told if mx is kax, express mx in terms of a, b, and the constant k. You must include the constant k. So take that mx as you are given it. All right, so that's our part B. So mx, we are already given that it is equal to k ax. So that's it. Simply substitute that because you calculated ax before here. So we have got what represent our vector ax. So simply substitute that in place of what ax to have or to obtain mx. So that was it. Our mx is equal to k times ax, which is this one. So that's minus a plus 2 over 3 vector b. So that was going to give us what? Mx. Multiplying by k times negative, that's negative ka. K times this 2 over 3, that's 2 over 3 kb. We multiply by k here. So that's going to be like this. All right, so that's our mx. As we can see, this is our mx. We are done. All right, let us move on. On C, DC is equal to H or A, expressed in terms of A, B, and H, vector OM. So let's start by DC because we are not asked to find it. Given that, let's find that DC first. So DC is this part here. So, okay, no problem. We're just gonna use the given what? The given answers or the given information. All right, let's also take these ones aside. We are going to need this. All right, so here, no problem. So let us have, like I said, DC first on part C. All right, so let's see. We are given that DC is equal to H or A. So let's find it. So that's H times OA. Are we having that vector OA? Vector OA was originally given from O to A as what? As A. So that's simply vector A here. That's our vector DC. So use that. You must include it in the root that you are going to use to calculate whatever that you are given to have your answer in terms of what? To have H. So the first one, item 1, was OM. From O to M, from O to point M here. How are we going to obtain that one? All right, so let's find out from what we have. To find vector OM, all right, we have got this part. Let's find a root because we are told that M is the midpoint. Remember, M here is the midpoint. This one. It is halfway. It is halfway. Half of OC. So let's say I have that OC, because OC from O to C, as we can see, it includes DC, because we are going to take it this way, OC, OD plus what? DC. So it is what? OD plus DC. So we can work from OC and have OM, because OM is half, it is halfway. So that is half of what? OC. So are we having the vector OC? No. Calculate it from the DC that we're given. OC is equal to OD plus DC, where OD is what? Is vector B, all right, plus DC. The vector DC, as we calculated, is what? HA. So that's plus HA, of which can start with A. So that's HA plus what? Plus B. So that's our vector OC that you're going to need here to find vector OM. So OM is half of what? Half of OC, which is this one. So it's half of HA plus B, just like that. So that was going to give us the vector OM, half of HA. That's going to be half HA, half of B, that's half of B. That's plus 1/2 vector B. So that's it. We have got OM from that calculation. All right. Then after that, we need to find MX. After OM, we need what? MX. So let's find a way or a route to determine or to find what? MX. So remember the concept, still the same. M is the midpoint, but this time we need MX, this one, from M to X. So to have it in terms of H, we must include what is what we have, like in terms of H. What is it that we have? We have got OM in terms of H. We have got this one, OM in terms of H. So to include H, finding MX, we can take this route from M to O, then from O to X. All right, as OX, let's see, OX, M to O is the one that has got H, all right? So MO, this one has got H. So we have included MO. From OM, we can find what? MO, because MO is simply minus OM. So we have got H there. So this is the best route, all right? So let's find MX. So that was it. So this is item 1, item 2. OM was item 1. And then item 2 is when we are finding what? MX. So as I said, we can take that route from M to what? To O, then O to X. From M to O, then from O to what? From O to X. So that was going to give us vector MX. All right, where MO is simply taken from what? OM. Remember the relationship. These two are simply the same. OM, then MO is the opposite. So you simply multiply by what? By a negative of OM to get what? MO. That's the concept. So this one is negative of what? Negative of vector OM. So that's negative of this vector OM, 1/2 HA plus 1/2 B. So it is to be multiplied by a negative. Then OX, from O to X, we are taking this in the same route, same direction as we had, and we have that OX. Remember, we calculated that one, which is what? 2 over 3b. So we have that one as a positive, just add as it is, plus OX, which is what? 2 over 3 vector b. You have it. So what you're going to simply need is to expand the brackets with the negative and collect the like terms on your simplification. So multiply by negative, that's negative half HA, negative times positive, negative half B, all right, plus the 3 over 2, 2 over 3 vector B that we have here at the end. So that is what you're going to have. And with this, collecting our like terms, we're going to have minus half HA, then the vector B and vector B. That part is where you consider the like terms. So you work with the coefficients. Minus 1 over 2 plus 2 over 3, you add that. All right. So that was going to give us 1 over 6, all right? This is going to give us 1 over 6 of what? Vector B. So that's our mx at the end of the day. All right, just like that. So you see, guys, it's just a matter of playing around with the information that you are given. All right, with the information that you are given, just try to play around with that information. So that's what you needed on this part. Then on D, using the results of B and C item 2, so B, we calculated mx. C item 2, we calculated mx. So use those mx values to, mx expressions that you have to find the value of h and the value of k. So we simply take these, all right? So that is what you need on this part D. So we're simply gonna equate the mx that we obtained, the first one here, all right? This was the mx that we calculated, remember? And the mx that we calculated, the second one, this one. These two, they are equal. So you take those two. Remember what I said about equal vectors. So you equate them in that manner. Solve the equations that you're going to formulate. You are done. All right, so here we can form for A, vector A, the coefficient minus K here, and this one is what? Minus half H. You equate them together. So that's minus K is equal to minus half H. You formed an equation. Another equation from what? From the vector B, you do the same thing. From vector B, the coefficient 2 over 3K, and that's a positive, and this one is a positive. So there, you're just going to take them as positive. 2 over 3K is equal to what? 1 over 6. That's our equation 2. Then you solve. But as we can see, these are two equations, guys. Solving these, sometimes take advantage of the equations. We can see that equation 2 has only one unknown. There's only one unknown value, k. So simply solve for k. Here there are two unknown values. So equation 2 is direct. One unknown value, so solve that one. Solve direct for k. All right, so you can solve this. It's either you're going to cross multiply or you're going to multiply by the LCM, which is 6. It is up to you, but you can solve this. Multiply by the LCM. 3 into 6, that's 2. Then 2 times 2, that's 4k. 6 and 6 cancels. So we're going to remain with the 1. So to solve for k, that's a product. Divide by what? Divide by 4. Both sides of your equation. So k is going to be 1 over 4. So with this value of k, you can simply substitute into that equation to solve for h. So that's minus k minus 1 over 4 is equal to minus 1 over 2h by substituting in place of what? K. So we can solve for h. Negative, negative cancels. The LCM here is 4. So multiply by 4 by 4. 4 and 4 cancels. That's 1. is equal to 2 into 2, that's 1, into 4, that's 2. So 2 times 1h, that's 2h. Divide by what? By 2 to solve for h. So h is equal to what? 1 over 2. So this is our h and this is our value of k. So that is what you're simply given. And with these values, you are now given to express or to use those values of h and k in D, the one that you calculated, express in terms of A and or B. So we just need A and or B only. We do not need any constant. All right. Item 1, mx. So you're going back to the mx that you calculated with these values. All right. So that is what you're going to simply need. All right. So let's find out. Okay. Let's find here our mx. Okay, let's just take this one up. Our mx is this one, so we're gonna just substitute in any one of these. All right, so that was what you are given here on E item 1. So you use any of these mx. So using the first one, mx is written in terms of k, so you substitute the value of k, 1 over 4. So it's minus k, that's minus our k is what? 1 over 4. 1 over 4 vector A plus 2 over 3 times our k. Our k is what? 1 over 4. So that's 1 over 4 vector B. That was going to give us vector mx, which is negative 1 over 4a. Then here, 2 into 2, that's 1, into 4, that's 2. So multiply the numerators, 1 times 1, that's going to be 1 over 3 times 2, which is 6. So that's vector B. All right, so that's our mx using what? The first expression that you're given for mx in terms of k, substituting the value of k that you calculated. All right. What about working with h? We are going to have the same answer even for this value of h that we are having if we are to substitute this one into the second equation, that is in terms of h. Another way, you are still going to obtain the same answer for that mx if we substitute h here. Our h is what? 1 over 2. So that's minus 1 over 2 times h. Our h is 1 over 2, all right, times our vector A plus this one is already a constant 1 over 6 vector B. So that's it. Multiply numerator to numerator. That's minus 1, 2 times 2, that's 4 vector A plus 1 over 6 vector B. So as we can see, same answer representing mx as before. We are obtaining the same answer. That is how we can see if we are actually in the right direction, if those constants that we calculated are actually correct answers that we determined. All right, item 2, that's vector DC. All right, so we need them without the constant. We can see before vector DC here was written in terms of h. So meaning to say, in this case, we are going to have that DC without H. So you substitute the H. DC is given as HA. So in terms of A, you have to substitute the H that you calculated. So that's 1 over 2 vector A. So that's it. We've got our vector DC. So that's how these questions can be given as. All right. So you simply need to work out as many questions, like I said, as many questions, guys, as you can. Try to do that so that you prepare yourselves for the exams ahead of time. For now, that is it. Till we meet again.